here's an easy and quick way to factor quadratics. So how this trick works is that you're gonna write 4 numbers, 2 on the left-hand side and 2 on the right-hand side. And now what the 2 numbers on the left are gonna be are x terms of the binomial. Because when we factor quadratics, we usually want to write it in terms of the product of 2 binomials. So we're gonna write the x terms on the left-hand side and the constant terms on the right-hand side. How this trick is gonna work is that we're gonna find 2 x terms and solely x terms that multiply to the x squared term and 2 constant terms that multiply to this constant that we see over here. So we can start off simply because we know that x squared is just x times x by writing x and x like that. And since we know that x times x equals x squared, we know that this is a valid choice. And so now let's write 2 numbers that multiply to 12. And this might take a little bit of trial and error at first, but eventually we'll see that this becomes a very, 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 very fast process. So let's just write, well, we know that 1 and 12 work because 1 times 12 equals 12. So let's just write 1 and 12 like that. So how we check that this possibility works is by considering the products of the numbers along these diagonals that I just drew. So the product over here, this diagonal, is going to be x times 12, and the product along this diagonal is going to be x times 1. According to this trick, if these 2 terms add up to the x term shown over here, then we know that the sum of these 2 pairs will form the binomials that we want to factor this quadratic into. So let's just add these 2 products that we just achieved. So x times 12 is just 12x, and x times 1 is just x. So adding those gives 13x. So we know that, since we know that 13 is not the same as 7, we know that 1 and 12 won't be a valid combination, at least for the constant terms. So let's try another pair of numbers that multiply to 12. Now let's try 2 and 6, which we know multiply to 12. The product along this diagonal is 2x, and the product along this diagonal is 6x. Their sum is going to be 8x, which we know is not 7, so we got to try again. Okay, now let's try 3 and 4. This product is going to be 3x, and this product is going to be 4x. Their sum is going to be 7x, which we know matches our x term of the desired quadratic. Now, because this is a working pair, we can say that this quadratic factors into x plus 3, because it's just simply the sum of this top row, times x plus 4, which is simply the sum of the terms in the bottom row. And so there you have your factored form for this quadratic. Now let's take a look at another example. So we're going to write out 4 numbers again. And for the left 2 numbers, because they multiply to x squared, we can just simply say that one number is x and the other number is x. So now looking at this term over here, you may see a negative and say that it's going to take a while to go through all the possibilities. But first, let's ignore that negative, and later on we'll include it. But first let's include a negative and factor 20 into its integer factors. So 20 can be written as the product of two numbers, and those two numbers can be 1 and 20, 2 and 10, 4 and 5, 5 and 4, 10 and 2, and 20 and 1. So because we factored 20 into pairs of integers, let's include that negative now. So remember that a positive times a positive is a positive, a negative times a negative is a positive. However, a negative times a positive is a negative, and a positive times a negative is a negative. So we need exactly one of these numbers in each pair to be negative. So we can just simply say that the first number in each of these pairs is negative. So we can say that -1, -2, -4, -5, -10, and -20 are all on the first column. So now we can see how this narrows down our search a lot. Remember that when we put numbers over here, let's say we just put 1 and 3 for now. This doesn't have to do with 20, but if we just put 1 and 3, then our diagonals are just going to be 1x plus 3x, which is 4x. So in general, if we have just two simple x terms on the left-hand side, we're going to have an x term resulting from this diagonal sum to be the sum of these two numbers over here. So considering this fact, we can just simply sum up all pairs of these numbers and see which one produces -1. Now to make this even more simpler, we can just notice that numbers differing by too much can't possibly produce a sum of -1. So to show you what I mean, let's just consider this pair. This pair has a sum of 20 plus -1, or just 20 minus 1, and that's equal to 19. So if we put -1 and 20 on the right-hand side, we're going to have a sum of 19x, which is not equal to -1, and differs a lot by -1. And so intuitively, we can rule out numbers that are way too far apart from each other in magnitude. 20 is a very large number, while 1 in comparison is a very small number. So adding a large number and a very small number is still going to be a very large number. Similarly, if you look at this pair, a very small number and just a small positive number is still going to be very small. So that can't possibly be -1. So we can rule out -1 and 20 because they're very far apart. -20 and 1. We can also rule out 10 and -2 because 10 and 2 is still very far apart. Indeed, 10 and -2 add up to 8. So we can rule out this. Again, we can also rule out -10 and 2. So now we're left with -4 and 5, and 5 and -5 and 4. So we can just now test these two possibilities and see which one indeed gives -x as our sum of diagonal pairs. Let's try -4 and 5. So -4 plus 5 is +1. And again, if you want to do it just using this visual, we can see that -4x is this product, and this diagonal has a product of 5x, and that's just x. So x doesn't match -1, so this is out. And this pair must be our final pair of numbers that multiply to -20 and result in -1 as our x coefficient. So if you really wanted to double check and it's always a good practice to do so. We can put -5 on top and 4, which gives -5x plus 4x, and that indeed gives -x, which matches our x coefficient in our desired quadratic. So therefore we can conclude that x minus 5, again the sum of the terms in the top row, multiplied by x plus 4. So just the sum of the terms in the bottom row will give our quadratic over here.